Right, welcome to today's stream on this revision series. We're going to be looking at integration of parametric functions with a specific look at partial fractions included into that. So without further ado, let's get on with our first question. It's quite a big one at 15 marks. So what I'm going to do is give you 5 minutes to have a look at, actually not 5 minutes, it's only a 4 mark. No, it's 4, then 6, it's 10. I'm going to give you 5 minutes to have a go at the first part of this question and see where you get to, and then I'll go through it. Right, here we go. So let's have a go at going through this question. So we've got this finite region between natural log of 2 and natural log of 4, but it's defined by these parametric equations. And we want to find this region. So first thing we've got to do is we've got to look at what the t value is when x equals ln 2, because what we're going to do is we're going to try and convert from these values of natural log of 2 and natural log of 4 when we're integrating y dx to some new limits where we're going to look at y, and we're going to be looking at dx by dt. dt is the formula that allows us to convert into the parametrics. So first of all, we've got x is equal to natural log of 4. If we have x equal to natural log of 4, we can see that t plus 2 must equal 4, therefore t will equal 2. And if x equals natural log of 2, then we can see that t will equal 0, because if x equals natural log of 2, t plus 2 must equal 2, so therefore t must equal 0. So we're going to be looking at limits from 0 to 2 for this. We also need to find out what y is. Well, that's quite simple. It's given here. But we need to find out dx by dt. So we know that x is equal to natural log of t plus 2. So we differentiate that, dx by dt, and we get 1 over t plus 2. So let's put that all into our formula. So we're going to integrate from 0 to 2. And we've got y, which is 1 over 1 plus t. Well, it's t plus 1, but I've written 1 plus t. Times by dx by dt, which is 1 over t plus 2 dt. And we want to integrate that. Now, as it stands at the moment, that times that is quite tricky to integrate. And if we do that times that, it's the same as 1 plus t times t plus 2. Actually, I'm just going to rewrite that around, so the same way around to make it more sensible. So we're going to have t plus 1 in there. And we're going to put this into partial fractions because they're much easier to integrate. And generally, when you see something like this, you should be hopefully thinking about putting it into partial fractions, although it's not always the case. It depends what's on the top. If the top was the derivative of the bottom, then we can actually just realise we could just do natural log of the bottom, or it might be something to do with the derivative of bottom squared. We might do a reverse chain rule problem. It all depends. Now, so 1 will equal a times t plus 2. I'm not going to go into detail how to do partial fractions. That's for another time. We're more concentrating on this. But what you realise is we want to think, what do we times top and bottom this by? We times by t plus 2 to create the same bottom there. So that means on the top I get a times t plus 2. And on the top here I'm going to get b times t plus 1. And they must equal 1. Now if we let a equal minus 2, then what we get is we get 1 is equal to, that's going to be 0, because minus 2 plus 2 is 0, times a is 0. Minus 2, so that's going to be minus b, so b equals minus 1. So I didn't mean to write a equals minus 2, I meant to write let t equal minus 2 because we're making that equal 0. And the reason why I said a is because I was thinking about how can I make this part with the a in it equal to 0. Now if we let t equal minus 1, then this part will become 0 and we get 1 will equal a. And we can just do that. So that means this integral must be equal to the t plus 1. The a part was going to be 1 over t plus 1 plus the b part, which is minus 1 over t plus 2 dt. Now we integrate that. The integral of this is natural log of t plus 1. And the integral of this is going to be minus natural log of t plus 2 between 2 and 0. Just think to yourselves, if you differentiate the t, this is a chain rule problem. If you differentiate the t plus 1, you're going to get 1, which gives you the top part of the fraction. And then remember, hopefully you remember the formula, you just put the t plus 1 on the bottom. It doesn't really matter. You could do the chain rule longhand if you want to. I'm not going to go into that now either. That's for another time. So put 2 into this, we get natural log of 3 minus natural log of 4 minus, put 0 into this, we're going to get natural log of 1, and then we're going to get minus natural log of 2. Now natural log of 1 is just 0, so we can just ignore that. So we get natural log of 3 minus natural log of 4, so we're going to put the 4 on the bottom, if you remember your natural logarithm, your logarithm formulae. Then we've got a plus natural log of 2, so that ends up being times on the top. So therefore our answer comes out as natural log of 3 over 2. Right, that is the integral part of it. So it's the 4 marks and the 6 marks part of the question. Sorry, I got a little bit confused. I only saw the 4 when actually I knew it was going to be a 10-mark question. But I gave you a bit of extra time over the 5 minutes. So bearing that in mind, find the Cartesian equation in the form C and state the domain. That's a 5 mark. I'm only going to give you 3 minutes to give you a go on that now and see where you get to, and then I will go through that. I'm going to just scroll up to the top part of the question so you can see that. Off you go. Right, so let's look at this part of the question. Right, we're going to try and find the Cartesian equation in the form y equals f of x. So let's just grab the x equals natural log of t. So let's put it part C. We're going to have x is equal to natural log of t plus 2. Now, if we raise both sides as a power of e, we get e to the x equals t plus 2. Take away 2 from both sides, so get e to the x is, take away 2, e to the x minus 2 will equal t. And then we're going to put that into here. So we're going to get y will equal 1 over e to the x minus 2 plus 1. Scroll down a little bit more to give us some space. So y will equal 1 over e to the x minus 1. Now we need to work out what the domain for the values of x for this curve. So the domain will be all the values of x that we can put in that will give us answers out. Now, where this fails in a domain is when the bottom of the fraction is equal to 0, because we cannot equal 0. So e to the x must equal 1 in this case. And e to the x equals 1 when this happens is when x equals 0, because e to the 0 is 1. So therefore, the domain will be x is a member of the reals such that x cannot equal to 0. Okay, because e to the 0 is 1, 1 minus 1 is 0. You cannot, this is undefined, 1 divided by 0, and that gives you your domain. Right, our next question, let's just zoom in a little bit on that. One more zoom, and there we go. Now, I'm just going to get you to do this all in one hit, and it's a... Wait, where's part B gone? Part B has disappeared off this. I'm just going to grab it for you and put it on the screen. You can get started on part A whilst I do that. I wasn't expecting that to happen. Anyway, I'm going to give you 5 minutes to have a go at the whole of this question, because bearing in mind what we just did, you should be able to do this one quite quickly. Right, let's get on into this question and see how we get on. So we're going to show the area of R is given by this integral here. So again, we need to find out what natural log of 3 as an x value is, as a t value is, and what natural log of 5 is as a t value. So if we have natural log of 3, then t plus 2 must equal 3, so t must equal 1 here. And if we have natural log of 5, t plus 2 must equal 5, so therefore t must equal 3 here. So we know that the area R will equal the integral of natural log of 3 and natural log of 5 of y dx, which equals the integral of natural log of, not natural log of 3, sorry, I'm going to move into t's now. And we're going to go from 1 to 3. And we're going to go y dx by dt, and this is the formula we always use. So we need to find dx by dt, so let's find dx by dt. And dx by dt is equal to 1 over t plus 2. So it's equal to the integral from 1 to 3 of the y value, which is 4 over t squared, times by dx by dt, which is 1 over t plus 2 dt. And we can see quite simply that that's obviously equal to the integral from there to there of 4 over t squared, brackets t plus 2 dt. And that was should have been quite straightforward, bearing in mind we've done a very, very similar question next. Now what we want to do is we want to find the exact value of the area R, and we're going to give our answer in the form of a plus natural log of b. And if you haven't quite got to the end of this and want to pause this and then carry on watching this stream after you finish that, then feel free. Anyway, first thing we need to do is we need to put this into partial fractions, just like we did in the last question. Now, this one is a little bit different because we should get a over t and b over t squared, and we need c over t plus 2. And a lot of people forget the b over t squared. And you need this because to get the denominator of t squared times t plus 2, you need some kind of denominator of t squared at the bottom. If you just put b over t for this repeating factor, then the common denominator t and t would be t. And you just all you'd get on the bottom is t times t plus 2, and it wouldn't be enough to get that bottom. So when you've got the repeating factor, instead of having b over t for the other factor, you have b over t squared. And any squared factor, whatever it is, you put b over that squared factor. So carrying on from there, we're going to times the a by t. Sorry, I put a bracket so I don't need. So I'm going to times the a by t, and I'm going to times it also by t plus 2. Because I times top and bottom of this by t over t plus 2, then the denominator becomes correct for what I need here. And b, I'm just going to have to times by t plus 2, and c, I just need to times by t squared. So if we let t equal to 0 first, let's do the easy one first. So we get 4, that's going to be equal to 0. This is going to be equal to 0. So this will come out as 2b. This is 0 because you've got 0 times 2 gives you 0. And you've got 0 squared times c gives you 0. So b will equal to 2. If we let t equal minus 2, the trick of this, if you haven't spotted it already, is to make something in the factors equal to 0 so you can eliminate variables. So we make the minus 2, we get 0 here, we get 0 here, so we just get c. So we get 4. Minus 2 squared is 4, so we get 4c. So c equals 1. Now, there's two ways to do the second part. You can let t just equal another value. Now, personally, there's quite a nice quick way of doing this is if you equate coefficients. Now, if we look at how many t squareds we got on each side, then you can see there are no t squareds on this side. So we put a 0 and we put equals because there's equals here. How many t squareds have we got here? We've got t squared times, we've got at times t, so that gives me at squared. So there's just a lots of t squared. And we don't need to write the t squareds down, we just write down how many lots of it we got. And we don't have any t squareds here, and we have just c lots of t squared here. So we know that a plus c must equal 0 to make all the t squareds work out. So all the t squareds on this side must add up to all the t squareds on this side. And so therefore a must equal minus c. So a equals minus 1. If you find that a little bit taxing, you don't have to do it that way. What you can do is you could let t equal something simple like 1. So you get 1 times by 1 plus 2, which is 3. So you get 3a. 1 plus 2 is 3, 3b, 1c. So you get 3a plus 3b plus c equals 4, and you know b and c, so you can find a. And you could do it that way. It's just, I like this because it gives me such a simpler equation, is why I chose that. Less working out my head, and also less chance of making a silly mistake under exam pressure, provided you really get this method. Now, if you don't get that method, it doesn't matter. So we're going to do our integral. So we're going to integrate from 1 to 3, 4 over t squared brackets t plus 2 dt. And what we get is, we're going to get from 1 to 3 of minus 1 over t plus 2 over t squared, putting all these values in. Our a value goes into here, and our b value goes into here, and our c value goes into here. It's plus 1 over t plus 2 dt. And if we integrate that, minus 1 over t is minus natural log of t. 2 over t squared, it's very similar to what we did before, so that's going to be, I'm going to change the sign of that because this is going to become minus 2 over t, or if you think of it, you might think of it as minus 2 times t to the minus 2, add 1 to the power is minus 1, divide by the power will give me the minus 2, and you can see I've got the same thing here, plus the natural log of t plus 2. And we're going to put that between the limits of 1 and 3. So let's work that out. So let's put 3 in, and we get minus natural log of 3, minus 2 over 3, plus 3 plus 2 is 5, natural log of 5. Take away from that, put 1 in. Natural log of 1 is 0. So just put 0 in there. Minus 2 divided by 1 is minus 2. Put 1 in here, we get plus a natural log of 3. Now, so I'm just thinking, oh yeah, that's okay. I made a mistake in my previous look at this question, by those things. Minus 1, okay. Right, so, no worries, I've just spotted I made a mistake last time, but I've got it right this time, so that's cool. So I've got minus natural log of 3, minus plus natural log of 3, so that's going to give me minus 2 natural log of 3, 2 lots of that. I'm going to get minus 2, minus and minus is plus, so I'm going to get 4 thirds, plus natural log of 5. Now, what I'm going to do here is I'm going to simplify this. This is going to be equal to, if I got to the minus 2, if I got minus 2, this is equal to natural log of 3 to the minus 2, which gives me 1/9 plus 4 thirds plus natural log of 5. So if that's 1/9 plus natural log of 5, that's going to give me natural log of 5 over 9. Alternatively, I could have just done to the power of 2 and had minus natural log of 9. Then when you're subtracting the natural logs, you realise you get a fraction. Plus 4 thirds. Okay, it's moving on. I'm going to I'll check that I've got, actually I must just quickly check I've got exactly the right answer for that. I've got a mark scheme. Yes, that's the right answer. So just checking I've got the right answer there, because my handwritten answers I didn't bother to check before, because I was quite confident what I got weren't correct. So let's see what we're going to do, part C. Find the equation, the Cartesian equation of this curve C in the form y equals f of x. Very similar to the last question we just did. So we know that if we've got x is equal to the natural log of t plus 2, then e to the x will equal t plus 2. So e to the x minus 2 will equal t. Now we know that y is equal to 4 over t squared, so therefore y will equal 4 over, now t is equal to e to the x minus 2 all squared. Okay, and if we wanted to put our domain in here, it doesn't really ask us to. We realise that this must be not equal to 2, so therefore, well actually, we're given that t is greater than 0, so if t is greater than 0, Okay, if t is greater than 0, then x must be greater than natural log of 2 will be our domain. Okay, if t is greater than 0, then x will be greater than natural log of 2, which is quite nice because if you put natural log of 2 into this, you get e to the natural log of 2, which is 2. 2 minus 2 is 0, and then you'd have an undefined thing. So that works quite nicely in this. There we go. So 2 questions where you have a bit of parametrics to do, and then you've got a spot that you've got to do partial fractions. And that is the key to doing these questions, and it's easily missed under exam conditions. Hope that's of a help. Diverge from the questions on the revision sheet. Those who've done this revision sheet, you'll notice, because these were more applicable, and also on the syllabus, where some of the questions actually had endings which were not on the syllabus anymore. Hope that was helpful. That will be the end of the stream. Good luck. Those of you still got to do the test. I'll be posting the test for those of you who want to use this as a revision resource in future with the videos solutions to the test after Thursday.